So, welcome to Introduction to Anatomy and Physiology. I'm basically in this series going to try and give general gist of how anatomy and physiology works and what you might learn in a course. So, anatomy, what is anatomy? It is the study of the structure of body parts and their relationship to one another. And then physiology is the study of the function of body parts, how they work to carry out life-sustaining activities. So, emphasis on anatomy is the structure and physiological is the function. So if we looked at, say, the heart, the anatomy would be its physical structure, how it's got the aorta, it's got atriums, it's got ventricles. And then the physiology would be the fact that it pumps blood, its function to pump blood throughout the body. Okay, so getting into starting terms you might need to know. You've got anatomy, and then you've got gross or microscopic anatomy, which is the study of large visible structures. So under that, we've got regional anatomy. It looks at all structures in a particular region of the body. System anatomy looks at, as you can guess, looks at systems like cardiovascular, nervous, etc. And then surface anatomy looks at all the internal structures as they relate to the skin. So veins and muscle masses and tissues and all that sort of stuff. Then you've got microscopic anatomy, so that deals with structures that are too small to be seen by the naked eye. So that's cytology, which is the study of cells, and then histology, which is the study of tissues. And then on physiology, we don't really have as clear subdivisions, but it's based on organ systems. So you've got renal, cardiovascular, nervous, all those sort of organ systems and how they work, what they function to do. And then it also often focuses on the cellular and molecular levels of the body. So it looks at chemical reactions and basic physical principles and chemicals and all that sort of stuff. But starting out, you should probably know that you've got something called the standard anatomical position. So your body is erect, your feet are slightly apart, your palms are facing forward, and your thumbs are pointing away from the body. So just a reminder, in all of anatomy, your left-hand side, what's on the left-hand side of the body is probably going to seem to you at first like the right-hand side, because you've got to think that, imagine you're a person and you're like turning all the way around. So what's on your left-hand side when you look in a mirror is actually going to be on the right. So you've got left and right. Oh, and just a little note, if I've said anything so far that doesn't make any sense, leave a little message in the comments. I'll try and cover it in the next video. So, moving on, another thing you probably need to know when you start anatomy and physiology or just anatomy is the different, like, sort of direction terms for the body. So, you may have heard of these before. So, this is kind of it's used instead of saying like it's to the left or it's to the right or it's up or down, because it's more scientific and it shows you've got like proximal and distal as well, which is not just describing if it's up or down, and it helps to actually show where body organs are. And then, so moving into the terms, first off, we've got superior. Like I said, you've got up and down. So superior is up, and you can say that for example, your head is superior to your abdomen. And then the opposite to that is you've got inferior. So as you can guess, inferior is down. You could say your phalanges or your finger bones are inferior to your chin or inferior to your elbows. And then the next few terms focus on what we call the midline of the body. So you imagine drawing a line right down the middle of your body, and anything that is more towards the middle compared to outside structures, we call that medial. So for example, your heart is medial to your ribs. I know I haven't drawn the ribs correctly here, ignore that. But then we've got the opposite. So lateral, which means that, for example, your ribs are lateral to your lungs because they're further out. They're like further away from the inner midline. Then turning the body around, just so we can see the side profile. So you've got anterior. This is not really easy to see from this diagram, but it just means towards the front of your body. So your eyes will be anterior to your ears. And then you turn that the other way around and you've got posterior. So as you can guess, that's just anything more towards the back side of your body. So if we use the same example as last time, your ears will be posterior to your eyes. And then, as I was mentioning before, we have things that are quite different to up, down, left, right, etc. We have what we call proximal, which basically means that if you take where the joint connects, so in this case, I've circled where the arms connect, like the shoulder joints, and you've got the legs. And so you take where that connection joint is, and anything that is closer to that connection joint is considered more proximal. So here you can see that your elbow would be considered proximal to your phalanges, which again, if you don't remember, that's the finger bones. And then on the flip side of that, you've got distal. So in this case, your phalanges would be considered more distal to your elbow because they're further away from the joint position. And then another thing you should probably know is that we have two main sort of categories of how you view the body organs and bones and systems. This also comes up in skeletons. So you've got axial, which consists of the head, the neck, and the trunk. And then appendicular is, well, I'm going to say everything else, but it's the limbs. So it is everything else. And then another thing we do is we actually split the body different ways. So if you want to see like a side view, what you do is you split it vertically, and we actually call this the sagittal plane. So this might allow you to, if you split it down the middle, you can imagine you could see the side view of the brain, you could see the side view of, you could see like through the heart, you can see all the way down the middle, and it'll show you what things are anterior, what things are posterior. Whereas if you want a different view, you've also got the frontal plane. And so that splits down the middle, but now we're going from a different midline. So you're going straight in half, kind of lengthways, if that makes sense. So if you cut it in half here, you're going to get a lot of organs where you've got half on one side, half on the other, and some maybe where they're only on that side and only on the back. So you can see here that you've got, for example, you get a front view of your brain. It'll probably cut through near the central gyrus. And then we have another common plane, which we call the transverse plane. And this kind of cuts at a horizontal axis. Not kind of, it does cut at a horizontal axis. And that just means that you can see everything sort of going up and down. So if, for example, we cut it where you can see here, you would be looking down into below the torso, and you could probably see the bladder, you could see bones, you could see muscles, you can see the muscle lines, the skin wall, everything like that. This could also be used for the brain if you want to see like through the middle of the brain, maybe you want to look at the ventricles, etc., etc. Well, we can go into that more later, but that's just the general gist. And then another thing, I know there's a lot of things here, I promise we're almost done. So your body also has cavities. So first up, we've got what we call the cranial cavity. You can probably guess from the shape what this holds. It holds your brain. Then we've got the vertebral cavity. Again, from the name and the shape, you can probably guess this holds the spine or your vertebrae. Then we've got the thoracic cavity, which actually has a couple of regions we'll go through in a sec. And then we've got the abdominopelvic cavity, which can also be separated into the abdominal cavity and pelvic cavity, but we'll put them both together for now. So as I mentioned, you can split the thoracic cavity into sections. You've got the mediastinum, which is actually all that middle section, but then it's also split again into your superior mediastinum and then your pericardial cavity. And if you know any medical terms, cardio or cardi or any of that always refers to the heart. So your pericardial cavity is where your heart is. And then on the left and right, you've got your pleural cavities. Again, medical terms, pleura or pleur or any of that usually refers to lungs if you don't know. So your left and right pleural cavities are where you would find your left and right lungs. You're probably wondering, why do we have cavities or holes or spaces for organs? Why do they need those? So there is actually a lot of functions they play, but one of the most common is going to be as a shock absorbent, or as they usually, what they can do is they store fluid. For example, in your cranial cavity, you're going to store CSF, cerebral spinal fluid, which we can go through in a later video, but that serves to protect your brain because your brain is a very fragile organ and you can have fluid around which sits on the inner layer of the cavity between what you might call the brain wall, which we can also go through later. But that fluid will serve some very specific purposes to make sure your brain doesn't pretty much get damaged and kill you. So last thing, I promise. But structural organization levels. So this one's pretty important, just being able to understand. Once you get it down pat, that's fine. You understand it, it's all good. So if you've ever done any chemistry or bio, or I think a lot of topics do go through this, but you start with atoms. So atoms are our smallest unit of matter. And then out of atoms, we make molecules. And this section, so atoms and molecules, are what we call the chemical level of organization. So we have different levels. And then next we have the cellular level, because cells are made up of molecules. So in the cellular level, you've got organelles, which if you haven't done any bio before, organelles are just small functional units. They're membrane bound and they're inside cells and they help it serve all its functions. So here you can see the mitochondria, which you might have heard is the powerhouse of the cell. So we've got an organelle, and then obviously cells, as I said, are made up of organelles. Here we've got a smooth muscle cell. And then next we go on to the next level, the tissue level. So tissues consist of similar types of cells. And here I'm showing you a smooth muscle tissue. As you can see, it's just lots of the smooth muscle cells combined together. And the next, organ level. So you can kind of get the idea now is that we're going up and up. It's building up to the next level. So on the organ level, organs are made up of different types of tissues. And your organs, remember, are your heart, your liver, etc., etc. So here I'm showing a blood vessel, which is made up of a lot of different types of tissues. And one of them is the smooth muscle tissue I showed you. And yes, blood vessels are an organ. Some people, I'd say, you wouldn't normally think of blood vessels as organs because they don't seem like the typical organ, but they are. And then organ system level is the next stage. So this is, as the name suggests, it's a system of organs. You have quite a few of these in your body and they function to keep it going. Without all of your organ systems working at the same time, you wouldn't exist as you were. So for example, the blood vessels contribute to the cardiovascular system, which, if you remember from back when I said heart, so this is your heart system. So your heart pumps blood around the body and keeps it all working and moving and transporting oxygen. And then, as I already hinted at, the last stage after the organ system level, your biggest one is the organism itself. So your organism is made up of lots of organ systems, which is made up of lots of organs, which the organs are made up of lots of tissues, and the tissues are made up of lots of cells, and the cells are made up of lots of organelles, and the organelles are made up of lots of molecules, and the molecules are made up of many atoms. That was very long-winded, but I think you get the idea. So that was a semi-quick introduction to what anatomy and physiology will look like. Leave a comment if you have any suggestions, questions, or anything like that, and see you in the next video.